Okay, it's 8 o'clock. We'll get started, okay? Let me see. We have Sarah. Hi, Sarah. How are you?
I'm good.
Okay, let me send out invitation to Sherry, okay? Hi, Sherry. How are you? Okay, we'll get started, okay? So first, let's review the schedule that we have so far. This review session so far we are handling quite well. So today we will be continuing to week 9, the computer and network hardware. So this is unit 4. And then we have unit 5. Then we are going to finish all the lectures. After we finish the lectures, there will be weekly 4 set of the practice, and we will just review the problems. But during these 4 weeks, it actually is 1 month. During this 1 month, you should go back to study the material that we have in these different lectures. So the best way to study it is that trying to get the slices that I gave you. So you come to here and then go to each chapter and then download the lectures, each lecture's PDF and study the PDF. That's one way you can study. Okay, that's one way you can study. Another way you can study it is you actually can go to end of year review right here, and then this one, go to Khan Academy. Khan Academy one, the good thing about Khan Academy is they do have a lot of problems in there. So basically you come to here and there's several units. They're units by themselves, okay? They have information, internet programming, algorithm, data analysis, simulation, whatever, okay? So basically after that, you can come to here to do your own review, unit by unit, based on the Khan Academy's order, okay? So for example, like, okay, unit 1, bit and bytes, okay? So how to computer represent data, binary bits and bytes. You have to, they will talk about it like binary and data, okay? So there is a video you can watch. So if you look at it, this video actually is also from Coda.org. If you look at it, it actually also is a Coda.org video, okay?
My name is Lenore Free. And
so it actually is also Coda.org, related to Coda.org, okay? So I can tell you that Coda.org actually is very popular. It's actually about 49% of the high school using AP, CSP, using the Coda.org material. Okay, so you can watch this one. You don't need to go to Coda.org location. You come to this one and then continue to look at these are different topics. Okay, so they are different topics. Then you go to quiz 1. After watching the video or study our related material, you come to the quiz. So there are extra quiz. So the parents quiz, we already done all of them. But if you continue to study for yourself, you come to here to do this different quiz. So like how many bytes in 2 bytes? So 2 bytes is 16 bits. So this one you pick C. Check. Okay, something like that. Okay, I cannot do anymore. So basically, this one is a very good review material. But while you read our reading material and their video here, okay, and then go one by one. But this is for the last 4 weeks. Okay, this is for the last 4 weeks. So if you don't get the link, remember that the link that I come from, I actually provide you the link in the right here on the left-hand side, end of year review. And then click on it, So this portion is for self-study, okay? So for self-study, so for the last month, you try to work on it by yourself and pick this one. This is very good things. Other than that, we will basically working on 4 weeks of the college boards problem set, 16, 18, 20, 21. Okay, 4 set. And we'll review all of them. So this 4 weeks is for reviewing. So now we are actually at 9. We are actually approaching the second half of the review course. Okay, so far, any question?
No.
At the same time, your project, some of you almost finished, like Sarah and Belinda, actually, both of you already starting to write your, creating your video. Both of you are actually approaching the end. So you finish that, that's fine, but you need to focus on studying this as well, okay? And then make sure when you finish your writing and everything and your video, let me know. I will try to prove reading for you, okay? Okay, anyway, that actually is about a review schedule. And let's go back to our Unit 4. Unit 4 is on hardware. Hardware has 2 parts, computer and the network. Okay, computer and network. So before we go for computer and network and looking at anything, I'll ask a question for everyone. So what really is a computer? Since we are talking about computer and network. So what really is a computer? This one for Helen. Helen, let you talk about what is a computer.
Something that can like process data and give a result.
Okay. How about Belinda? What's your definition for computer?
A type of technology used by humans to like help them.
Technology that people have. Okay, whatever. Your definition is quite different from Helen's. Okay. How about Sarah? What's your definition for computer?
It can store and transfer data.
Then what's the difference between computer and cell phone? Since you talk about transfer the data. Okay, it's okay. We are just actually do brainstorming. How about Sherry? Sherry, how about your definition?
Like a machine like can like compute data.
Compute something, okay.
Yeah, compute something.
Mhm. How about Stephen? Stephen, how about your definition?
Something that calculates stuff and returns it.
Calculate and return it. If not calculation, what will happen? If it's reasoning, what will happen? Your AI is doing reason, there's no calculation you will do. Okay, actually everything that what any one of you talk about is not bad, okay, close. So why we actually look at the computer, so we try to have a definition for the computer, so you know what really is doing computation. Okay, so what is computation? The first one is mathematical structure. So what is mathematical structure? When we say F equals MA, this is a mathematical structure. Your acceleration of a particle that move forward, and then you provide different force. The force may have certain angle that you apply to your object. Okay, so this is one set of computation, but this one right here is physical phenomena. Left-hand side is the mathematical modeling. So using mathematics to model your physical phenomena that create mathematical modeling, and we exercise on the mathematical modeling that is computing. Right, that's computation, okay? So computer that is a electronic devices that realize computation. Okay, electronic device that realize computation. So you have some sort of devices. These devices can be a cell phone, can be a computer, can be an iPad, can be an iWatch, can be a car pad that actually you have in the Tesla, can be a robot. As long as that device realize computation, so you have some computation that F equals ma. You realize it on the computing device and carry out the computation, then we call this one is a computer. So the definition is very flexible. It's not only x86 CPU that's actually a computer. It's not. Anything that can realize a computation and perform the computation on top of it, that's called computer. Okay. And then next one is computer science. So any science is using this thing to solve problems. So you have physics, that's physical science. So physical science is the science of physical objects kinematics. You talk about how things kinematics. You talk about how things move and how things work and how things drop and how things collide with each other and how things emit energy. That is the physical science. The science to study that's called physical science, that's called physics. So chemical science, that actually is a science that study the chemistry, that talking about how atoms, electrons, molecules, how these different things work. The chemical reaction, talking about the science of the chemical reaction and use that to solve problem that's called chemical science. Biological science, the same thing, okay, similar. And then everything can be modeled by mass. Everything can be modeled by mass. So mass is so important. Okay? And then anything that we call it computer engineering, we call it electrical engineering. We call it chemical engineering. Anything called engineering is a discipline, the study of engineering discipline to make computer. So electrical engineering is an engineering discipline to make electronic devices. Chemical engineering is an engineering discipline to make chemical products. Okay, so this is very clear. Next one is artificial intelligence. So artificial intelligence is what? Based on whatever we have talked about so far, which word can represent this artificial intelligence the better? Helen, artificial intelligence is what?
It's like a
Give
program
me-
that can like
Give me one word. Give me one word that I already talked about today that actually represent AI the best. So artificial intelligence is something. This is something. Tell me this is something.
Like a computation?
Yes, that's the right word. AI is a computation. Again, what is computation? Helen, what's computation? I just finished that. Tell me what's
Like-
computation.
Doing math, like to represent something?
Not enough. You are still too blurred. Belinda,
Like to calculate something.
no. I talk about it today. I don't use this kind of language. I use different kind of language. You are kind of trying to say it, but not exactly. How about Sarah?
To like process something.
No. How about Sherry? What is computation? Again, I ask you another time. All of you.
Calculate.
Not calculate. Calculate is a very low end technique.
Okay.
Stephen, your turn.
I'm not sure. Wait,
Try.
Yeah.
There's no way you say I'm not sure. Today I'm trying to teach you in the PhD way, okay? If you go to PhD study, this is the PhD way. We do all kind of interviews. The professor will ask you question, you have to answer the right concept.
To calculate given the input.
No, you are still using your own language. My word is mathematical modeling. I talk about this many times. If you ask me 1,000 times, I'm still talking about mathematical modeling. What kind of mathematical modeling? Large language model is actually one kind of model. That math model is not large language model. That's AI. AI is a computation. What kind of computation? You need to have some mathematical modeling. Large language model is one kind of model. You can use a reinforcement learning modeling. You can use a statistical reasoning modeling. A lot of different modeling. Now, nowadays, most popular one is LLM, large language model, DeepSeek, ChatGPT. So AI is a set of mathematical modeling. That is one computation. So the computation will happen on computer. So basically, you got a computer. On top of it, you have Windows that or sometimes Linux. And this is OS. On top of it, you have compiler, say you have C double plus compiler, whatever. And then your AI is loaded on top of it. It's a set of computation that represent the mathematical modeling that perform the computing on top of the hardware and software. That's AI. Is that okay? Hello, is that
Yeah.
okay?
Yes.
Why I ask everyone to open your mouth and talk about it? Because someday you need to be like me. You go to college, you become a professor, you become someone, you have to talk about your own idea. And your idea must be very clear, very clear. Say, you say something, everybody know what you are talking about. So right here, am I very clear about my AI definition of AI? I think I'm very clear, right? I have no
Yeah.
ambiguity. I talk about AI is a computation. A computation is a mathematical modeling, and this most popular mathematical modeling right now for AI is large language model. Large language model actually is a model that model the natural language that actually provide a grammar and the grammar processing. So we may use the regular expression to express to actually formulate it, and then they will translate from tokens. We do tokenization and break down the tokens into the grammar, and then from the grammar we translate to Spanish, right? So this is very clear. So someday when you go to some summer camp research, you write technical paper, or you do research, or you talk to a professor for interview, or you try to do publication for your paper, you need to be very, very clear about what you are talking about. So you must train yourself to be a good teacher, a good presenter. Okay? I believe I'm a very good presenter. I can just jump into the right concept and tell you what it is and tell you what it is not. Okay? Tell you what it is and what it is not. It's okay. I'm just giving you the training. Okay, you're a high school student. We don't actually expect you to perform like a PhD, but that's the training that college you want to have. Okay, you write your essay to apply for college. You need to talk about what you are talking about. Okay, so we define computer. Computer is an equivalent, electronic devices that actually would realize computation, and a computation is the mathematical modeling of some physical phenomena. Okay, these are something you need to bear in mind. This is the computer science you want to learn. And I give you the basic principles, the basic knowledge that you need to know. Okay, this is AP computer science principle. You need to know about the basic definition of computer things. Okay, anyway, we know what is computer and what is mathematical modeling. We know what is, let's get started. Okay, so basically you need to know about device, computing device. Okay, computer is computer device. Computer organization, how this device is being built. What is instruction set? What is parallelism? How is a serial computing? And how pieces can be put in parallel. And computing model, sequential computing and parallel computing. And what is the hardware, what is software? So basically, these are the topic of this chapter. We won't go into very much detail, but we try to give you some idea. And then second part of this lecture, we may start to talk about network. Okay, when we reach network, we'll define what's network. Okay, at this moment, let's don't talk about network, just focus on computer. So first one is a computing device. A computing device is a physical artifact that can run a program. So run a program. So program is mathematical modeling or a set of computation. A set of computation, you use your computing programming language to model your physical phenomenon. That is a physical artifact. And that actually putting onto your computing device. So it can be computer, can be tablet. Here missing a T, okay. Server, router, smart sensors, okay. These different things are computers. So a computer do have an input, processing, output. Yes, some students could say computer is data processing. That's true, but not exactly the good definition for computer, okay. Your computer do have an input, output, and processing, but it's actually very low-end view of the computer. It's not wrong, but it's not really capturing the key idea. So next one, computing devices. Some example computing input devices include, but not limited to keyboard. So here are the input: keyboard, mouse, scanner, microphone. Okay, webcam. Okay, this is okay. This is not hard. Output device, I think there are some output devices as well. Okay. Okay, so you do have these different input devices. Okay, and then these are output, 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 input, computer. Okay, input. Okay. But robots. So what's the relationship of robots and computer? Anybody know what is a robot? What's the difference between robot and computer?
Like a robot does something in the physical world?
Yeah. So if people say this is computer and this is robot, so how can you tell the difference between robot and computer? Right? These are philosophical problems. You need to try to understand it, right? Anybody know? About Stephen? What is computer and what is robot?
One is autonomous, and then another one you have to give it input.
One is what?
Automatic
Which one is automatic?
robot.
Okay, robot is automatic. So basically, computer is like this. This is computer. So robot is actually a special kind of the computer. So but robot is a special kind of computer. So robot usually, yes, it involve automatic response. Okay, it will involve automatic response. And computer may not have automatic response. Okay, computer follow instructions. Okay. Computer organization. So you need to know about how computer is organized. So this chart is a basic view. This one is not a very advanced view, but you need to know about what's input, what's output, what is control, what is loop, what is memory. Okay, in APCSA, we already explained it. So right here, I don't repeat it again, but you basically need to know what they are. And then your user system software and application software, operation system, these are software. So AI is one kind of application software. AI is right here. It is on top of your Windows. Okay. AI is one set of computation. So this is a computer system view. You have CPU, you have ROM, you have RAM, you have I/O. So what is RAM? Anybody know what is RAM? Steven, do you know what is RAM?
Random access memory.
What does that mean?
It's like to store temporary things.
Okay. And what is ROM?
I'm not sure.
Anybody know what is ROM? Helen, do you know what is ROM?
No.
So RAM is actually random access memory. So random access memory means that you have a memory bank like this. And you talk about which row and which column. This row, this column, and then you get a memory from here. That's called random access memory. This is compared to the old day, you have a tape. You have a tape. So you have a tape, you cannot randomly access it. You have to go from the beginning part of the tape and then read the whole tape before you see the data. That's called serial memory. Okay, compare with that. So nowadays, the DRAM is dynamic RAM. SRAM is static RAM. Okay, and both are random access memory. That means that you use the address, row and column address, then you can access it. Okay, so Sherry, what is a DRAM? What is dynamic RAM? What's that?
Isn't it just like storing like data, like temporary data?
Yeah, but what is DRAM and what is SRAM? D is dynamic. So what is dynamic? This S is static. So what is DRAM and what is static? What is SRAM?
Like saying like SRAM, like the static one
Hmm?
is like faster, is it?
SRAM faster, yes. SRAM faster, yes.
Because
This one faster. And then what is SRAM? But you did not answer what is SRAM. Anybody know? So when you go to buy a computer, they give you like, oh, okay, I have 1 terabyte of the DRAM. I'm sorry, usually not 1 terabyte, it's usually like 32 gigabyte of the DRAM. And then the 1 terabyte of the hard disk. So hard disk is going through the I/O channel. Okay, but DRAM actually is 32 gigabyte. And usually the SRAM is smaller. SRAM may be only a mega SRAM. Okay, the word static and dynamic is different. Dynamic means that you have a capacitor. And when you charge it, you will put some electron to there. So you actually do charge up your capacitor. But because that your device may have leaking problem, so the electron will free away. So after a certain time, your voltage may drop from 5 volt to 2 volt. Then you go from 1 to 0. So that's not okay. So every certain clock cycle, you need to refresh your memory to boost it up back to 5 volt. That kind of memory is called DRAM. Okay. So DRAM is a RAM that you need to refresh them. That's called DRAM. SRAM, on the other hand, you charge up the capacitor using a driver. And then you will keep at the 5 volt. It will never drop. So this they have an active device, keep driving it, keep it at the 5 volt all the time. So it's static, means always the same voltage. That's called SRAM. Okay. ROM means the read-only memory. Okay, so usually ROM is for BIOS, basic I/O units. Okay. And then your putting that your initial program that you boot up your computer is put into the ROM. Okay. So first you actually read the program from the ROM and run it, and then you load your program from the hard disk to the RAM and start running it. Okay. So this is the basic system architecture. Okay. And then you have program counter to point into the memory to fetch some instruction. And then when you fetch the instruction, you roll it to instruction register, and then you decode it and give the control command and do computation using the ALU. Okay. So this one is your CPU structure. Okay. And this one is a RISC-V CPU structure. Okay. And then there are different kind of CPU. You have super pipelining, super scalar, VLIW. Okay, different approach to design a CPU. This won't be tested, okay? So don't worry, this won't be tested. Just give you the idea. And then you may have single core processor, you may have 4-core processor, you may have 16-core processor. A core plus one single core processor means that you have a CPU with some memory and then talk to outside I/O, that's called single core processor. If you have multiple CPU and memory, multiple CPU and memory, and they have shared memory and a system bus, so you have like 4x4 16 processor putting into one CPU. That's called multiple core processor, okay? That's called multiple core processor. So nowadays, actually, most of the computer that you buy, let's actually go to Best Buy. So Best Buy laptop, MSI laptop, okay? So let's see that actually go to Best Buy, MSI, US. How come we need to choose USA or Canada? Okay, anyway, this one actually is a MSI. It actually is a core. This is CPU, i5 CPU, okay? And then this one that's actually go down to the spec. Okay, there is a feature. Okay, there's a feature, and then actually it's an Intel Core i5 CPU. Okay, so they are up to 4 performance core, 4 efficient core. So actually totally 8 core. Okay, this CPU is very low end. It's actually, but they do have 8 core, and then they also will have 1 GPU. Okay, they also have 1 GPU. Okay, so that's actually the number of processor in your computer is called how many core. Okay, that determine whether your program can go parallel or not. Okay, and they are level 1 cache and level 2 cache and level 3 cache. Okay, and you can organize in this way or in this way. Okay. So how you put your processor and how you actually put your cache, that actually is a very important design issue for microprocessor and GPU nowadays, okay? And here another GPU design. And you may also have TPU for tensor processing unit, okay, or for Google. So we just briefly talk about the computer architecture for you. Okay, so that's about the computer organization. Next one is instruction set architecture. Okay. Okay, now, who know what this instruction set architecture really means? We call it ISA. So who know what is instruction set architecture? Let me see. Sarah, what is ISA?
I'm not sure what that is.
Have you ever heard of this word?
No.
How about Helen? Do you know?
No.
How about Harrison? You just come in. Do you know what is instruction set architecture?
No.
No?
No.
Anybody know? Stephen, do you know?
No.
First, you need to know about what is instruction set. You know instruction set first before you know what is architecture. So what is the instruction set? Instruction set is your 80x86 instruction set. That's your Intel instruction set. So when you write program for Intel, Intel give you a whole i86 instruction set guideline. So instruction set actually is the machine code. So before you write program for a computer, you need to know what computer you have. You have i86 that has one kind of the computing machine code. If you use a M1, A1 from Macintosh, Mac, it's totally different instruction set. So these cannot talk to this. These two, they use different machine code. So the instruction set is the machine code. Okay. So let's see, you can do x86 instructions set reference. Okay, so these are different instructions that provided by Intel. Okay, here let's actually try to have something that actually say ADD add. So you have add IMA to AL. So you have a register called AL plus 8-bit data, and then sum together to put back to AL. This instruction called ADD AL IMNA. This actually is one machine code. So basically, when your Java actually or your C++, you do compiler, and compiler finally would translate to this kind of assembly. This is called assembly code. And this assembly code have one-to-one mapping to your machine code. So machine code will be 1101, 1110, whatever binary format. But when you read it, it's in this kind of the instructions format. Is that okay? So in a way, you have your C++ program, you compile it, so you become a x86 executable. So this executable actually is machine code of this kind. Okay, but this machine code of this kind may be the program may, as long as the instruction set is the same, it may be run on an i5 processor that's running 900 megahertz clock. So the clock is slower and performance lower. You run that. You may have an i9 that run at the 5 gigahertz. Run extremely fast. But the same program that you compile to can run on here or here, different processor. Then we call them instruction set ISA compatible. So we say that your computer is x86 compatible computer. And this program you compile to cannot be run on Macintosh. So if you want to run on Macintosh M1, sorry, M1 has M1's instruction set. It's totally different from this x86 instruction set. And right here, if your instruction set is compatible with x86, no matter how fast your clock is, it doesn't matter. You just slow down actually going faster. The computers are compatible. Okay? Is that okay? So you can also say M1 instruction set. Okay, they are M1 instruction set as well. And this is totally different from the instruction set we look at in x86, okay? So a different one, so they are not compatible. Okay, that's instruction set. So basically, instruction set is the interface of your CPU and the software. Your OS is written on top of instruction set. Your compiler is on top of instruction set. Anything above instruction set architecture is software. It can be machine code, can be application, can be OS, can be compiler, but it actually is all software. Anything below ISA is CPU, is circuit, is chip layout, it is hardware. So hardware or software, depending on you're talking about, it is a program or it is a circuit. It is a circuit, is a hardware. It is a program, then it is actually a software. And then your hardware and software interface is this ISA. Any of your program need to be compiled to your machine code. Your machine code operate on your machine. So that's called instruction set. Is that okay so far? Hello?
Yeah.
So basically, this is AP computer science principle that actually should be taught in this course, but too bad your AP course is kind of flawed. Not really teaching the right material. This is supposed to, when you study hardware, you need to learn this, okay? You need to learn what is inside here, what is ALU, what is register profile, what is whatever you need to know about this. So you know how to pick your processor, okay? So this is arithmetic operation, add the subtraction, okay, set less than, okay, whatever. This is arithmetic operation. You also have logic operation, and or equals or, okay? You have 32-bit instruction format, okay? You have low store operation, low from memory, store back to memory, okay? You have branching instructions, okay? These are different assembly. So basically, these are related to CPU design, okay? And then after that, you need to know about parallelism. AP CSP exam do tested more on parallelism. So this is section more tested because it's easier. Usually they tell you to count how many seconds that can be finished, a task can be finished. So you need to know about what is data parallelism, what is instruction level parallelism, what is task level parallelism, what is multiple programming, okay? When we talk about parallelism, these are different parallelism. Okay, these are different parallelism. So for example, data parallelism compare with instruction set parallelism. Okay, let's assume that you do have a matrix A, B, okay, C, D. You need to multiply by with a vector X and vector Y. Okay, let's assume you have a matrix times a vector. So if you do a regular program, say you read using the Java, you write the program. So you say for integer I equals 0, I less than a dot length, I increase. Okay, good. Second line, you say integer j equals 0, j less than a1 dot length. Okay, j increase. Okay, and then you do this row times this column, this row times this column, and then you end up with two numbers, and using nested for loop to finish that. So that's the way that you do using the instruction level parallelism, and that is slow. That is slow. So when you do GPU, you should put your X and Y over here. Okay. So you understand what got sent to here. And then you should have your A, B, and C, D right here. So your A, B, C, D, A, B go this way, X, Y go this way. So in here you do multiply and add. So here you will have AX plus BY. Here you have a CX plus DY. And then now create a new vector. So you have the vector new equals n times vector. But it's actually at the data level. And this is why your GPU is faster. Because you do not need to use a for loop. You just send the data here, here, and then go. Pop, 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 and then you gotta read it. Okay? So parallelism, talking about how you efficiently move your data. So the one who can do the AI well, basically is an efficient mover of your data. How fast can you move your data to create your computation? That's called parallelism, parallel processing. Parallel processing is the key. When you go to college, you want to learn the best parallel processing in order to master AI computation. Does that make sense? Okay. So if you can prepare your data, always put it into your GPU, okay, to perform matrix operation. You have a lot of linear algebra that you learn from your college course, and then you have all kind of transformation you put into a linear matrix operation, and you pump your data. A lot of matrix keep pumping the vector times vector plus vectors, and then you utilize your GPU. That actually is very fast. If you don't do that, you do for loop, and then for loop, and then for loop, and then for loop, you are slow. Okay, you are slow. So basically right here, if you can do it more data parallelism, it will be faster. And bigger program, multi-parallel program, it will be slower. Okay, but you can look at different level of parallelism, data level parallelism, instruction level parallelism, task level parallelism, and multi-programming. Multi-programming means that I use multiple computers to compute one thing that is slower than I put into data level parallelism. Okay, so these are different levels of the parallelism. They do share different property, but they are very key in the very important. Okay, any questions so far?
No.
So next one is the SIMD parallel paralysis or MINDI. SIMD is a single instruction, multiple data. Single instruction, multiple data. You load your single instruction and your data loaded to there, and you run it. This is called SIMD. Okay. If you have multiple instruction, so this one do add, this one do multiply, and your data pump to different devices. This is called MINDI. MINDI is faster than SIMD. Okay. Multiple input, multiple instruction, multiple data. That actually is faster than SIMD. Single instruction, multiple data. Okay. These are also different parallelism. Okay. Just let you know these are available for parallelism. Okay. And superscalar is higher up execution like this. This is called superscalar. Okay. This one is the super pipeline. This one is super pipeline. Okay. These are the how you stack up your instruction so you perform faster. Okay. Right here, we don't go into the detail, but just give you the basic idea of how parallelism can be done. So this one is task level parallelism. Okay. This one is instruction level parallelism. Okay. And GPU is data level parallelism. There are different kind of parallelism you can achieve. Okay. And multi-threading, single-threading means that your program can run by itself, or you can start 3 different processes and then merge later. That's called simple processor multiple threading. And you can also have multiple processor multiple processing. Okay, it's different. These are different multi-threading processing. Okay. And then core CPU, how you do parallelism, okay? Serial processing or parallel processing. So multi-programming is using multiple computer to do one task. Let's go multiple programming. Multitasking is you do multiple tasks on the same CPU. So you do job A and then jump to job B and then coming back to job A and then coming to job C and then coming back to job B. You have one CPU, but you switch among different processor, among different tasks. That's called multitasking. So this one is the slower one. Multi-programming means that you have multiple multiple computer to do programming for you. Multi-processing means that I have multiple processor to do processing for you. So this one, this is 3, this one fastest, this one middle, this one slow. Okay. Anyway, just give you some basic idea. Okay, here they are comparison. Okay, these are okay. And object-oriented programming, basically, you may need to send the message for different object. Okay, these are the ideas. Okay, so when we talk about the AP exam, they basically want to know what is sequential programming, what is parallel. So you need to know how things can be parallelized and how things need to do serial. Okay, and then sum up the total time you need to have. Okay, whatever. We kind of end right here. So next one is your cloud computing. Cloud computing means that you doing computing at the server side. So nowadays we talk about some data center. The data center is the cloud computing. So you do your computing not on your computer, but at the remote side to do computing for you. That's called cloud computing. Okay. So usually the cloud computer can be a supercomputer, can be an AI trainer. Okay. Next one is the hardware and software. So far we talk about many of the hardware. Then outside of the hardware, you need to have operation system. This is Linux or your Windows or your compiler. These are different system software. And then all of the program that run on this system software is called application software. And AI usually is a set of a application software. Okay. Okay, you need to basically know about every single term right here. Okay, you need to know what do they mean. So let's see. Okay, you need to know all the term. Okay, you also need to know about all of these different terms for hardware and software. Okay. And you need to know about what is the application software and system software. We will wait until the problem and then talk about more about this. Okay, at this moment, very hard to say. Okay, operation system is the software that manages your system resource. Okay, like Windows or your Linux or your Macintosh OS. Okay, so they do all kind of a job for you. That's called operation system. Web server is your notebook is a client. You send an HTTP request to the server, and the server do computing for you, and then send back the response. This is called web server. Okay. Okay, you pretty much need to know about what is application software. Okay, we are done with computer. Okay, we are done with the computer. Computer actually right here, not a lot of things. Now let's actually continue on to talk about network. So let's have a 5-minute break. Okay, we'll come back for the network. Okay, so 9:05. Come back on 9:05. Okay, let's just stop on computer and we will start networking. Okay. Okay, it's 9:05. We are back. Any questions so far? Hello, any questions so far?
No.
No? Harrison, are you okay? Hello. Hi, Harrison, hear me? Hello. Hi, Harrison, you hear me?
Yeah.
Oh, Belinda, are you okay?
Yeah.
Okay, we'll get started. We'll study for do networking. So previous part is mostly on computer. Next one, we are going to talk about network. Again, before we go into network, we need to know about what is network. Okay, before we define it, then what really is network? This one for Belinda, what is network?
Um, is it like the internet?
Network is not internet.
It connects devices.
The connect devices, yeah. How about Harrison? What is network?
Like a system of like things
Of what?
of like computers or um like CPU.
No, that's not network. How about Helen? What's network?
Just like interconnected computers.
Interconnected computer. So in one network, minimum how many computer needed?
Two.
Two, yes. A network minimum number of computer is two. So your computer A connected with computer B, then we create a network. Okay, that create a network. Is that clear?
Yeah.
Just one computer connected to the other, that's already a network. Sarah, is that okay?
Yeah.
Stephen, is that okay?
Yeah.
Now, okay, this is the definition for network. Next one, what is a router? Anybody know? You may have know about your home have router, or sometimes you call it Wi-Fi router. You go to McDonald's, they have their Wi-Fi router. You go to a library, they have their Wi-Fi router. You go to your Starbucks, they have their Wi-Fi router. You go to school have their Wi-Fi router. So what really is a router? Sherry, what is a router?
Not sure.
Not sure? How about Sarah? Do you know what is a router?
I think it's like connected to like all the devices to provide like connection.
Kind of. But a more clear definition is a router is a computer that provide routing service. So basically, a router is a computer by itself is a computer and that provide a routing service. So let's see. Let's assume that you are here. Your friend is here. I want to send an email from point A to point B. It is impossible that I connect a line that directly connecting A and B. Nowadays, we don't do that, so that's impossible. So basically, in the middle, you may have different points. So you may go from here to here, from here to here, from here to here. That's one routing. You may go from here to here, from here to here, from here to here, from here to here, from here to here. That's the second routing. You may go from here to here, from here to here, from here to here, from here to here, from here to here. That's the third routing. So end to end, A to B is end-to-end communication. And then this guy, this guy, this guy, this guy. Anything in the middle, any computer in the middle that provides service for us is called router. Is that okay?
Yeah.
Is that clear?
Yeah.
Any of the computer in the middle of somewhere to provide routing for you, that's called a router. Router is a computer that performs specific service for routing. So basically, let's look at 1973. Let's look at 1973. DARPA Internet. Okay, DARPA. First, you need to know what is DARPA. DARPA is Department of Defense Research. Defense Advanced Research Project Agent. Okay, so basically they are performing the research for Department of Defense. It's called DARPA, okay? Everyone who do PhD usually know what is DARPA because a lot of the PhD scholarship is coming from DARPA. Okay, so from DARPA in 1973, this one, at that time, it's probably too small. Let's pick a bigger one. Let's use this one. There are totally 23 universities, that including USC, UCLA, Lawrence Berkeley Lab. There's LBL, Lawrence Berkeley Lab, Stanford, Xerox Research Lab, Los Alamos Research Lab. Okay, Hawaii. There's no UC San Diego yet. Oh, this is 1977, but there is another version in 1973. That's the original version. This one is already new. So you have Utah in there. You have UIUC, Illinois. You have UT Austin. You have ARPA. ARPA is DARPA's shorter name. Okay. There's no difference on before it, right? It's an ARPA. London. Okay, and here you have NYU, Lincoln Research Lab for MIT, MIT 6, Harvard, Rochester. So there are 23 universities beginning to set up this ARPANET as the first internet. So any one of these different computer on this map is the oldest routers. Is that okay?
Yeah.
Is that clear enough? So in the old day, we just have these different so few computers on the research. Okay, in the 1977, there is another version in 1973 that actually is older. Okay, the one that I just picked, I think this one is, there's another one that actually is older. Okay, there's another older version. This one is older. This one probably 1973, but the picture is too small, so I do not use it. Okay, now okay, actually, this one is 1973. So network created at that time, 1973, September 1973. Okay, this is the initial setup. There's no Texas, if you see. Okay, no Texas in 1973 version. Okay, so at that time they set up the internet and then start to operate. So that is the beginning of the network. So network is computer to computer connection is called network. Router is the computer that provide routing service for you. Okay. Then at your home, you have a laptop. So you have a laptop right here on top of your desk. Your brother is playing PS5. Your mother is actually watching K-drama. Your dad is maybe using the desktop to watch stock market. Okay, every single one of them. They do have a Wi-Fi router from AT&T. So everybody talk to it. Okay, and then this go out. So this one is also called router, Wi-Fi router. Usually the Wi-Fi router is talking about this one. Okay. And this one is a router. So sometimes they are big guys. They will try to actually kind of put in the device to listen to your device. That's called routers, access point. So they may oversee your activity. Okay, that's one kind of flaw. Now later we'll talk about, okay. But at this moment you need to know about this your Wi-Fi router and your home network. Okay, your home network. So this is your home network. Okay. So far this is your home network. And sometimes if you are in the same building, we call it intranet. If it's the same building, we call it intranet. It's an internal network. We call it intranet. Okay. And one building, a hospital, they have their own intranet. They're connected to the same router and getting out. Okay. But sometimes they are big guys who may listen to your activity. That's called ruckus point. Ruckus. That is router. Ruckus access point. Okay. So this is unauthorized listening of your network. Unauthorized. Okay, this one is you search internet. Here is a ruckus access mode is a unauthorized Wi-Fi network device. So on your router, someone actually dig a hole and put a device to overwatch your performance. That actually is a ruckus access point, and that may steal your information. Okay, by hardware. Okay, so this one is ruckus access point. So, okay, let me give you this link. Okay, this one is internet and location. So so far we talk about intranet. Internet is a network within a building. That's called intranet. So you got a building. You have multiple level, and you have a lot of computer. They all connected to a certain router, and that router goes through fiber channel to your internet service provider. Let's say this is AT&T, and then go into the internet. Okay, so this Wi-Fi within the building, we call it intranet. Okay. Now next term. Next term is the one you hear more popular. So then what is internet? This one for Harrison, what is internet?
Like the online like system where you can like browse through like information.
No. Network already can route through the information, so it's not, you are not defining internet. We are talking about specifically what is internet. Belinda, what is internet?
Is that a type of network?
What type of network?
International?
No. International is international. Here, inter is inter. How about Stephen? What is the internet?
It's like a network where you can access information.
That's still network. That's not actually defined beyond the network. How about Sarah? What is the internet?
You can transfer data between different like computers.
That's still network. That's still A computer transfer to B computer. That's not defined internet. So Sherry, what's the internet?
Like having access to.
No, you actually, so none of you know it. That's fine, okay? So here you have intranet. Intranet means that you have access point and you have multiple computer connecting to it. So intranet is a network, right? So this intro is between computers, internal. Another location, there is another intranet, another network. There's another network. Okay. So from this router, you get started going to here, 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 going to here. So the network among network is called internet. Network for the network is called internet. Is that clear enough? Inter, that's among. So your networks, the network that working among the networks, that's called internet. Is that okay? Hello?
Yeah.
So intranet, that actually is a network itself. A network is a network that connecting multiple devices together. You can transmit the data to yourself or your neighbors or your friends in the same network. And then your network connected to another network through the outside network. And they may go through a router in Utah. They may go through a router in Illinois, or they may go through a router in London. So that kind of the network among network, that's called internet. Okay, that's called internet. Okay. So next one. So that's internet. So next one is World Wide Web. So web is a network locally. Okay, this is one website. World Wide Web means that the web that connected worldwide. www is the web that connected worldwide. It's called World Wide Web. Okay. So internet is the network among network. And in order to build up your internet structure, so we need to have internet protocol. Because you talk to me, I talk to you, there must be certain kind of protocol. Otherwise, you don't understand me, I don't understand you. So we need some sort of protocol. So protocol is the communication standard set up among the network, so for people to follow, so that you can talk to each other. It's okay, that actually is called protocol. So this different term, network, internet, protocol, you need to know about the definition very clearly. Otherwise, you will be in trouble. Okay. So this one is the 7-layer architecture. You need to know what is protocol. Protocol is a set of rules that govern exchange and transmission of data between devices. So this network protocol. Okay. It's a set of rules. It is a set of rules. Okay. HTML is one protocol that actually is a document standard, the language of a website. HTTP is a level 7 protocol to transfer your hypertext. Okay, HTML, hypertext transfer protocol. That's called HTTP. Okay. Okay, so this is vocabulary you need to remember. So you need to know what is protocol, what is character set, what's data frame. These different terms you need to know. Okay. Before you communicate, these are something you need to negotiate. So you know your character set. I know your character set. I know your protocol. You know my protocol. Okay. And that protocol is called 7-layer architecture. You have application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. This is 7-layer. You need to remember what they are. Everything you need to remember. As a computer scientist, you need to know. Okay. So usually the lower level, 3 level is related to hardware. Top 4 is related to software. Okay, you need to know about what is TCP, what is IP, what is UDP, what is Ethernet, what is Wi-Fi. Okay, these are something you need to learn. Okay, so today in today's this lecture, in this lecture this week, we don't talk about the top 3 level. We actually we don't talk about the top 4 level. We only focus on the hardware 3 level. There are 1, 2, 3. Physical layer, data link layer, and network layer. We only talk about these 3 layers today. Okay. So the relationship of physical layer is that physical layer, you need to send your data in the sinusoidal wave. We call it radio frequency. And your 101010 need to be converted to this. and then your receiver convert it back to 101010. So anything handle the digital to analog and then coming back to analog, this is called PHY. This is layer 1, physical layer. Is that clear? From digital to analog, and then coming back as an analog signal, going back to digital. This kind of communication standard, we call it layer 1. Layer 1, okay? Layer 1 is talking about signaling. Harrison, is that okay? Can you understand?
Yeah.
How about Belinda, can you understand?
Yes.
How about Sarah, can you understand?
Yeah.
Okay. Now, layer 2. Layer 2 is you have a computer, you do have a computer board. Say you have a modem. It connected to another computer. There is another board. So this is a board-to-board communication. Or printed circuit board to board. Board-to-board communication is layer 2. Is that clear? Hello? Is that clear?
Yeah.
So in a way, you at your home, you may have your computer, you have a Wi-Fi, it talk to the router. So your computer to the router, from this one to this one, actually is board to board. They also go through the radio frequency, but this is actually a level 2 to level 2. But in the middle, you may become level 1 to level 1 in the middle, but you can kind of consider in that you have level 1, level 2 communication. So you go in from level 2 down to level 1, and level 1 transmit to the other side to level 1 and coming back to level 2. So this is board-to-board communication, we call it level 2. Data link layer. Data link means board-to-board. Third one is network layer. What is network layer? You have USB connected to Berkeley, connect to Utah. So USB connected to Berkeley, this 1-to-1. This is level 3 to level 3. So inside USB, you may have a laptop talking to a Wi-Fi. Wi-Fi talking to a fiber channel, and fiber to fiber communicate to Berkeley's fiber, going back to Wi-Fi, going back to a main computer, and that main computer routing to Utah. So anyway, inside USB, you have level 2, and then right here you have level 3 communication from USB to Berkeley, level 3. So level 3 is network layer. That means that when one network communicating with another network, then it's called level 3 network level. So level 3 would require IP Internet protocol. Internet protocol is called IP. It will require Internet protocol IP address. So USC may have a 3.92.2.7. This is the IP address for USC. Then it connected to Berkeley. So Berkeley may have 9.112.251.7. So this is Berkeley's IP address. So from one IP address talking to another IP address, this is level 3. That's network protocol that actually requiring IP address. Is that okay so far?
Yeah.
Okay, now I'm going to erase it. So Stephen, what is level 2?
It's when like when the data moves through the network.
You did not actually remember what I'm talking about. So Belinda, what is level 2?
It manages how devices, how they like communicate.
You did not remember. You did not remember. Harrison, what is level 2? I'm teaching you how to efficiently get the concept. You must keep the core idea. It's called ball-to-ball communication, sir. You have to talk about this right away. When we talk about level 2, you have to talk about this ball-to-ball. From one communication board, PC board to another PC board, that's actually ball-to-ball. That's level 2. You just need to remember this. Okay? I checked 2, 3 people, but none of you remember. So Sherry, what is level 1? Hi Sherry, what is level 1? Physical layer.
Like when the computer
You don't remember, that's okay, but remember, if you study any subject, you must keep understanding the core idea. That's more important. Once you grab the core idea, you will never forget it. How about Helen? What is level 1?
It's like how the network like physically connects, like through like cables and stuff.
What is the keyword that I'm using? Let me give you one more time. It's a signaling, and one more time. It's actually analog to digital to analog, and then analog go back to digital. It's converting to different signal. It's actually signaling, right? I emphasize this many times, right? When I talk about physical layer, right?
Yeah.
You have to remember, it's actually just provided from 11011 converted to analog signal, and then the other side receive analog signal and then convert back to 1011. This is actually from digital to analog signal coming back as an analog signal going back to digital. This kind of the signaling part is level 1. Level 2 is board to board. Okay, you have to remember that I never change my talk. I'm the same, I'm consistent. Sarah, what is level 3?
Does it involve like the protocol
What kind of protocol?
for transferring information,
Yeah, what kind of protocol?
like TCP, UDP?
No. You jump too far. That's level 4. Level 3 is IP address. You need to transmit from one IP address to another one, from USC to Berkeley. Is that okay? So
Yeah.
basically what I want to say is that this is 7-layer architecture. You need to remember each layer's job, how they work on it and how they perform, and what kind of error they may happen, how to actually do fault tolerant, how to provide the duplication to avoid it. You need to study the key concept, but you need to exactly know each layer, what are they doing. And you need to remember the keyword that I give you. Layer 1 is signaling, you are analog to digital, digital to analog. Level 2 is board to board. You have one board connected to another board, that's actually level 2. And as the remote computer connected to remote computer using the internet protocol, that's called level 3 network layer. Right? You have to study like this. So like 10 years later, even if you become someone like me, like 50 something, you still remember the subject clearly. Okay? Not very hard, but you need to grab the core idea. Okay, we talk about this because we want you to learn it. Okay. So the TCP and UDP is level 4 transport layer. Today we don't talk about it yet. Okay. So your communication is like from your browser that's level 7, kind of converting down to level 1, going to the modem, and then going up to level 2, and then going back to router, say this is USC node, and then going down and going back to Berkeley, and then going down to New York, NYU. Okay, let's assume this one is Caltech. Okay, going to NYU. So you have multiple layers like that. Okay, this is the logical internet model. Okay, so right here, actually between say USC and Caltech, it's not really 1 to 3, 3 to 1, and 1 to 3. It may be 3 to 1, and then 1, 2 to one board, and then 2, 1, and then 1, 2 to another board to 2, 1, and then 1, 2 to another board, and then 2, 1, and then 1, 2, 3, and then going to different router point. Okay. It may be something like this one right here, a little bit of being cutting short. Is that okay? So this topic for the network and hardware, you must be able to tell some story and being able to talk. Okay, otherwise you don't really learn this kind of stuff. So internet, you have wired. Wired is this one, RJ45 connector. So this one is copper. So copper would attenuate. That means the signal will weaken, and then you need to have a booster somewhere, like maybe every 100 meter, 100 feet. You need to boost it up. Okay, this one's copper. So this is one of the media. Copper media as the wired Ethernet. This one is fiber channel. So here we have the glass, fiber or glass, and your light put on here, and then you transmit. So this one almost no loss. Okay, no degradation on your signal. And then this one is a coaxial cable. Coaxial cable. Okay. And this one usually used for TV before, analog TV before, okay, or ADSL. Okay, this one coaxial. It's also copper. Also have degradation problem. This one is Wi-Fi. Wi-Fi means that you actually go from your PC to the radio frequency and then broadcast by radio, and then the other side receive it. So this, we have a copper, fiber, and also radio frequency, different media for the for level 1, okay? So far, okay?
Yeah.
The Ethernet may use 100 BT, okay, 100 bit per second transmission, and also may have 1 gigabit 5-level signaling. This is 3-level signaling, okay? Different standard may use different signaling, but this is the physical signaling. And this one is the CDMA, FDMA, TDMA signaling. As for these, what are these? You have to ask Qualcomm, what is the CDMA, okay? These are different communication standard for radio frequency. So that's a different protocol, okay? You have 5, you need to have different protocol. So right now we are on 5G, okay? You have different protocols. So what is the protocol? Protocol is a set of rules that govern the exchanges. So usually your phone, you may talk hi, and then the other guy say hi. And then cuts the time, okay, it responds 2 o'clock. Okay, so this is one communication. Your PC talk to server is the same thing. You have this kind of exchanges for the protocol. Okay, you set up the protocol first. So protocol is a set of rules that actually govern the communication. Okay. And HTML is one protocol that used for level 7 to represent your website. Okay. HTTP is a transfer protocol. HTTP and HTML are different. This one is a document standard. HTTP is a communication standard. These two are different. HTTP is used to provide protocol for the website request. ASCII is also a protocol. It's actually the character set protocol. Okay. So application protocol is a level 7 protocol. You have file FTP, okay, HTTP, SMTP. This one for email. POP3, DNS. Okay. So all of these you need to know, especially DNS. We'll talk about this later. Okay, we'll talk about this later. At this moment, you just need to know about the 7-layer architecture. Let me see where we are. Okay, level 7, we talk about it later. And then HTTP connection, you have a lot of handshaking in order to set up a session. Okay, HTTP is send one request to the server, they'll send back another response. May include the web page that you request. Okay, next one is that in the level 3, we need some address. So it's called IP address. Okay. And then your video, you cannot actually transmit the whole video to the destination. So you need to chunk them into smaller chunk. Each one of them maybe 1 KB. Original video maybe 1 giga. So the small chunk of the data, we call it a package. Okay, so your network level actually is transfer package after package to different IP address. So you may have a network, and then one package may go this way. Another package may go a totally different way. But later they will reassemble them back. Okay, so that's protocol is the rule of how they actually time different package and then reassemble them. Okay. Okay, next one we have an example of the battleship. So battleship is a game like this. Okay, you put your different ship, and then you kind of bomb the enemy's ship. And red one is a hit. Hit means that nearby there is one ship. Okay, there's one ship. And white one means miss, means that there is no ship. So you have 5 different kind of ship: carrier, battleship, carrier, cruiser, submarine, destroyer. Okay. And then whoever got bombed and sink all of the boat will lose. Okay, so take turn. everyone will bomb the game once, okay? So basically, this is the battleship, okay? And anyway, let's look at the internet game, okay? So there are many, many battleship games. Let's go for this one. Not this one. This one is okay. It's loading, okay. So basically, this one I'm playing with a remote computer or a remote person. And then you need to have a set of duo that actually I understand the duo and he understand the duo, and then we play together on top of this internet. Okay, so we go through the protocol, and then we set up using the same protocol to communicate. So this is a battleship game just to tell you when we write a software how to establish the game. Okay, so let's do process. So I have 6 different ships to put it somewhere. Okay. Okay, continue. So this is the protocol. Right now, I'm playing the game. So you need to say bomb it. Hit, right? I hit that he missed. So this one is a hit. So I'm going to bomb the nearby location. Another hit. So I'm going to hit another one. Like a big hit. Okay, I think one of these both. Okay. Anyway. We are not here to play game, okay? We are actually just showing you that's a protocol. If you want to play this game, you can actually look at it by yourself, okay? So basically, this is an example of using protocol to communicate and then play an online game. So everyone follow the same rule, and then using the different set of rules to do communication. Okay, so this one is what we want to show you for the game. Okay, so today we are up to here. Okay, we're already 9:53. So today we cover the computer and the network, and then for the level 1, 2, 3, and also talking about the need for IP address and protocol. Okay, up to here. The next one we'll talk about for tolerance and some other topic that related to top 4 level. Is that okay so far?
Yeah.
Okay, any question? No? No, you need to watch the video one more time, okay? Make sure that every single subject will remember the chorus concept well, okay? That's not easy, okay? Don't overlook it, okay? when you go to do the problem, you will see the importance of knowing these different things carefully. Okay? Okay, good night then. Bye bye. Good night.
I thank you.
But thank you.
But
Bye bye.